A very good morning to all of you and welcome to RRLogic. My name is Ayonam and I am the director of RRLogic Systems Private Limited. We are based out of Bangalore. Today I'll be talking about compiler development for custom software programmable processors. This talk is directed at those who are either in the process of developing a custom software programmable processor or have already developed one and are looking for compiler development for their processor so that they can develop their software using a higher level language like C or C++. Before I get to the core of the talk, I would just like to give a brief introduction about RRLogic systems. RRLogic was founded in 2011 with a vision of being a one-of-its-kind one-stop shop in India for compilers and developer tools, providing outstanding value to customers through quality by design and timely delivery. Prior to 2011 also, we were as a group and we were operating under various companies since 2006. So strictly speaking, it's a 14 years old journey. In these 14 years, we have executed several compiler projects on both turnkey as well as resource augmentation model. And today we have more than 70 man-years of combined in-house compiler expertise. In the management team, we have Anil Gupta, who is our principal advisor. He is a semiconductor industry veteran with over 35 years of experience. And most notably, he was the MD of Applied Micro India and ARM India. And then myself as the director of the company. I have over 23 years of hands-on experience in compilers and developer tools. And I have led and managed engineering teams for the past 20 years, and we have delivered several projects. As far as our capabilities go, as I said, we have over 70 man-years of compiler development expertise in-house, and we have been working with several open source and proprietary compiler frameworks. Amongst the open source compiler frameworks, we have worked with the GCC, we have worked with LLVM, Open64, and then the other binary utilities in WinUtils, the assembler and the linker, and then the debugger in GDB. And then we have ported several user-level libraries like the glibc, uclibc, and newlib. All of these are C libraries. Then we have ported libstdc++, that's the standard C++ library. And then the libpthread, which is the pthread library. And all of these were ported for different process architectures depending on the requirements. And we have also worked on some legacy compiler frameworks like LCC, SDCC, Swift. On the proprietary side of things, we have worked with the EDG framework, the C2RTL compiler framework named Spark, and then some other proprietary frameworks from HP and AMD. We also have quite a good amount of expertise in the area of binary translation, which is a form of compilation. And when we talk of binary translation, it includes translation, instrumentation, and optimization. And each of these can be performed either statically or dynamically, which means at runtime. If it is statically done, then we could do it either link time or at post-link. And then we have, from this binary translation extends the emulation techniques. And we have decent expertise in emulation and virtual machines. We have worked on ISA simulators, emulators, and interpreters. Then we have also developed virtual machines like Java Virtual Machine. We have implemented the entire Java language spec in the virtual machine in the classic interpreter mode. And we have worked on validation and benchmarking of compilers and bringing them up to speed with their industry counterparts on other process architectures, like the more standard ones like the x86 and ARM. And these include validating using the GCC torture suite, the Perennial, the Plum Hall, and then bringing the test results in line with x86 or ARM test results. And similarly, worked on spec, Geekbench, and the EEMBC benchmarks. And again, worked on the analysis of the performance and bridging the performance gap between target process architecture and standard architectures that are comparable to it. Then we have other capabilities like parsers, We have done linting tools, specific code optimizers, code generators, which are highly targeted to particular processors, and then of course maintaining certain legacy compilers and tools. Coming to our offerings, we offer clean room development of a compiler code for your custom processor on any of the two most commonly open source compiler frameworks, namely the GCC and the LLVM. Depending on your requirements and your preferences, we could choose either of them because both have their own pros and cons. Or we could choose any other open source framework of your choice, or if you have a proprietary framework of your own. We could develop custom passes, which is over and above a normal port to any of the processor frameworks we already talked about. This would exploit the features of your processor which are normally cannot be expressed probably in a simple high-level language, so or which are not very obvious to the existing optimization passes and which cannot be translated to your processor's features. We could write such optimization passes which could exploit features in the high-level language code and translate them to your processor's features. We could also write passes to improve performance over and above the passes that are already there in the high-level frameworks. We could also look at custom language constructs, which is when we could exploit some features of your processor using adding new custom language constructs to the existing C and C++ constructs. So we could write such customizations and we could translate those language constructs to your hardware's features. Then we could do the performance characterization, which would include performance analysis, improvement, and of course the benchmarking. Here we could take your workload and we could analyze the performance on your processor vis-a-vis a comparable industry processor, and we could try to figure out the bottlenecks and try to bridge the gaps in the performance by improving on the compiler, either in terms of custom passes again or in terms of the backend port. Then we could also help you with the validation and certification of these tool chains. Many a times your customers may require certain certification for your tool chains because the processor that you may have developed is being used in a very safety critical application. So we could help you with these validation and certification tool chains. We could help with the maintenance and support and upgrade of your existing compiler tool chains if you already have one. And lastly, we would also say that if you have desire to build your own compiler team but do not know where to start, so we could help you build the compiler team and we operate it for a certain duration of time, and then we transfer the team lock, stock and barrel, and you could then operate the team on your own. We would help with the hiring, the training, and everything else that is involved with setting up the compiler team. Now, this part of our offering is a very specialized part wherein we offer you ISA consultancy. This is something that we have noticed with a few of our clients that they were busy designing their processors. They overlooked the need to map the processor's instruction set architecture to the high-level language and to see how the various constructs of the high-level language would translate to their instruction set and whether their ISA was sufficient enough to actually handle that. And because of this, we came up with this idea of providing this consultancy. So as part of this, first of all, we try to identify the instructions that may be required based on the kind of workload that you are operating. And we look at the workload on an x86 platform, we look at the kind of instructions generated on that, and then we try to map with your architecture's goals, and we try to suggest the kind of instructions that you might need to handle that kind of a workload. The next part is, as I said, with the language side of things, wherein we look at the C, C++ language dependencies on the instruction set, and we suggest you various instructions that you may want to implement to support various features of the C, C++ language. The third thing that we do is with respect to the instructions for custom language constructs, as we talked about earlier. So we suggest you what kind of instructions you need to add to handle the custom language constructs that we may come up with, things that could help with the kind of workload that you're trying to program. So this is a consultancy that we provide to you to do the compiler with us. Then we move on to the other developer tools that you'll need in your tool chain, things like the assemblers, the linkers, and the profilers. So these are code profilers, and we provide you all these through the GNU bin utils. We develop a port for GNU bin utils for your processor. And we could also add a custom assembler or linker passes depending on your requirements to the passes that are already provided in the GNU bin utils. And we can also help you with implementing the link time optimizer, although there are certain passes that are already implemented in GCC and LLVM to do the link time optimization, which allows you to optimize the program at a global level and not at the file level that a typical compiler optimizer does. So apart from the passes that are already there in the GCC and LLVM, we could write custom passes to support your process architecture. After you've written your source code, the next thing that comes is how to debug issues in the source code. And you need a debugger. We help you port GDB to your processor, both in remote as well as native debugging modes. Most of the times when you're developing a custom IP, it's mostly that you would need a remote debugger mode. And in that, we could do a setup of GDB that could work with either your hardware target, that is if you already have the silicon ready, or if it's still on the drawing board, we could develop a simulator, and the GDB could help you debug code on that simulator at a source level. We could also add customizations to GDB to handle the various assembler and linker quirks that you may have added in terms of the custom assembler linker passes. If there are any changes that GDB is required to handle, we could do those. We have done that for a particular customer. Then if your silicon is not ready, you would obviously want the simulators, the instruction set simulators, and they could be cycle accurate or just instruction accurate, and we have done both. We could also help you build profilers to profile the code that is running on your silicon. And these profilers could be for very deep embedded devices also, which do not have OS support. Typically profilers need that, but we have done for even deep embedded devices without any OS support. And if your processor has any hardware-based event counters, we could help you develop tools, develop compilers that could read those event counters, things like the instruction count, the cache miss, the TLB miss, and those kind of events. And we could provide you with tools that could help you visualize these numbers for your workload. For the last part of our offerings, we offer you workload characterization. As part of this, we would analyze your workloads based on the compiler generated code. So which would mean we would look at the workload on a standard x86 kind of platform, and we would see the compiler generated code on those platforms. And then we would map that with a kind of process architecture that you're planning, and then suggest you what kind of instructions can be used to handle this kind of a workload. We could then identify the various bottlenecks that are part of this particular kind of workload. Then we could help you with the hardware and software execution model to mitigate these kind of bottlenecks. So which would essentially mean which part of the workload gets done in the hardware and which part gets handled in the software, and how the runtime architecture of the system and the compiler together would bridge the work that is done in the hardware and the work that is being handled in the software. We could also help you with hardware and software partitioning of the code, which part gets done in the hardware and which part gets done in the software through either automated tools or user-directed tools, which would be essentially semi-automated. The user would give certain directions on which part should go in hardware and which part in software. And then we would help you partition that code automatically, and the compiler compiles the software part of things, and you could possibly have a mechanism to handle the hardware part of code in your IP. Finally, we offer the expertise in binary translation. And binary translation is typically a path employed to support legacy software on new architectures. So if you have an old architecture and you have a a lot of software code base on that. Your customers have that, and you want them to move all of that to the new architectures. Typically, it takes time to port all of that software to the new architecture. So this binary translation can be used as a bridge between the old and the new architectures, which would help you as well as your customers to port the legacy software faster. And the time it takes to actually do the real port, during that period, you have the legacy software still available on the new hardware architecture. It could also be used for optimizing precompiled binaries for improvements in newer versions of an existing architecture. So for example, you have added a few new instructions, and you have some legacy binaries over which you don't have control, and you don't have the source code either. So how do you make those binaries make use of the newer revisions of the architecture? So we could recompile those binaries using binary translation, and we could generate instructions that would use the new architecture's features. Similarly, we could use the same mechanism to instrument binaries for profiling. Suppose you have a customer and he is using your hardware architecture, but he is unable to allow you to stop his system and debug the problem that he has. So in those situations, we could dynamically instrument those binaries while they are running on the customer's setup, and we could do a profiling, and we could identify the problem while the customer's systems are running. So this is yet another use of the binary translation, and we have deep expertise in all of these, and we could offer you that to port your software from an older architecture to a newer architecture. So these are some of our present clients with whom we have worked, and amongst them, as you can see, there are ARM and AMD, the two big chip makers, and we have medium-sized companies like VeriSilicon, QuickLogic, Microchip, Sankhya Labs. Some of these Indian companies like Sankhya Labs, Vayavya Labs, Indian service providers like Tech Mahindra. Most important of all, the Indian Defense R&D, DRDO. These have been our clients, and we have had repeat orders from some of them. And these are some of the clients from the past, which is before we formed RRLogic, when we were as a separate group with an umbrella of other companies. Amongst them, as you can see, Atmel, Cypress, Montalvo, and a few other Indian companies like Metalogic Circuits and Mango Technologies. I have a few case studies, but in the interest of time, I'll take up only two of them. The first one is we did a vectorization for a custom media processor, wherein the GCC toolchain was upgraded for vector processing. We basically wrote the backend part of it, and then we allowed for vectorization of custom instructions and striding and scatter gather. And what we implemented in the middle end of GCC was the tail vectorization, which essentially vectorized the tail of the loop using custom mask registers that were available on that platform. And one of the key value propositions of this particular effort was that we could vectorize most of the OpenCV code. And the next case study is to do with the link time optimization in GCC for Intel x86. So we wrote two independent passes. One pass did a constant propagation across functions. This was a whole program-wide optimization. And the second was a pass to the structure optimization, which is essentially to figure out the unused fields in the structure and remove them, and then reorder the members for minimizing the padding in structures. And the constant propagation, it worked across function calls with single write and multiple read paths. And we had upstreamed this particular two passes, and it is in the process of being accepted by the GCC community. I'll skip the remaining case studies in the interest of time, but you're most welcome to take a look at our presentation, and I'd be glad to answer any questions that you may have. Here is our contact information, our registered office, and our operational premises. There is the Google Plus code to locate us on the map, and the web page, the email address, and my phone number. Feel free to contact us in case you have a requirement, or even if you are curious about what we could do for you. And big thank you for seeing through the entire presentation. Thank you.